Well, hello, and I am more than certain that you probably remember the character that is pictured here on the title slide, and I assure you that this video was made without the assistance of lightning or bats or Transylvanian references or... Now, hold on a second. I said without Transylvanian references. Okay. In this video, we're going to talk about the ways that certain tasks can be done and the ways that we can count them up. And so let's get right into it, shall we? If you're curious about the number of different license plate combinations there are available in the state of Iowa, or the number of different combo meals you can choose from your fast food place that you like to eat at, you can use something that's called the fundamental counting principle. And if you have distinct choices to make for several different situations, and you have so many ways to make the first choice, and so many to make the second, and so many to make the third, then all you have to do is just simply multiply all of those different numbers of choices together in order to get the total number. Now, probably the smart way that I set up these problems is I draw blanks that represent my choices. And, I could have a lot more blanks if I wanted to. I'm just kind of using this as an example. And then in each one of these blanks, I fill in the number of choices that I have. And then ultimately what happens is I multiply all of those numbers together to get a final answer. So that's my typical strategy for setting these up, because I think it's just a little bit easier to do it that way. So let's dive in and try to see if we can get more specific here. All right, so here in the great state of Iowa, a standard license plate, and when I moved here a few years ago, I got the standard license plate, and it's typically 3 character letters followed by 3 number characters, and we want to know how many different license plate combinations are available. Okay, so when it comes to making this decision, you have 6 choices to make. So I'm going to fill out 6 blanks is what I'm going to do here. And I need to think about the number of choices that I have for each and every one of these blanks. Okay, so these first 3, for example, these first 3 right here, I know that these all must be letters. And there are 26 different letters in the alphabet, and I'm going to go ahead and just not be very restrictive here, just to make this example easy. I could repeat them if I wanted to. Now, if I can't repeat them, that's another story, and we'll talk about what that means in a future example. For the other part of the license plate, I have digits. And I have the digits 0 through 9, so there's 10 of those that I could choose from as well. And if I go and multiply all of those numbers together, obviously I'm going to get a really big number here. And that number works out to be, let's see, let me copy this right. I think I got it, 17,576,000. So there are over 17 million combinations for license plate that are possible just on that basic combination that you get when you just go to the DMV and say, yeah, give me whatever, I don't care. There are some people that, obviously they'd rather spend the money and get a vanity plate of some kind, or, a clever little phrase. I've always said that, my math teacher one would look like that, empty set, kind of signifying what's in between my ears. Okay, now that we're done with that, we've got this idea of different sandwiches, different side items and drinks at Wendy's. And if you have to pick one of each, how many different combo meals are available? Well, you have to pick a sandwich, you have to pick a side, and then you have to pick a drink. And if there's 10 and 5 and 8, just multiply all of those together and you have 400 choices. So if you could possibly eat at Wendy's every day for more than a year and have a different combo meal each day. That's kind of surprising that it works out to be that much. Okay, another choice or another example here. A lock can be set to a 3-character sequence using letters and numbers from 0 through 9. How many possible combinations are there? Okay, well, we're not putting any restrictions on here. So now I've got to think about how many choices there are for each one. And with 26 letters and 10 numbers, there's 36 of each. And that would allow me to come up with, as soon as I get the calculator to do its thing here, 46,656 different possibilities. Okay, now, having a quick conversation here, I imagine that, maybe you want to stay away from O's and I's because they look too much like zeros and ones. Or, that's just something to think about. But if we're not putting any restrictions, that's what we're looking at here. Now, there are some questions requiring fundamental counting principle that have special requirements that need to be thought about carefully. And again, the best thing to do is to just draw a slot for each choice and ask yourself how many choices you can have. If you need to do some color coding or special symbols, that might help you out to draw attention to tougher situations. And, we think about an area code. The first digit of an area code cannot be 0 or 1. And if you did just a quick little survey or even just went and researched even the number of area codes in Iowa alone. There's 515, there's 712 for eastern Iowa, there's 319 for the eastern part, there's I think a 641 if I'm not mistaken. I want to say there's another one around the Quad Cities. I think it's 563, but don't hold me to that. None of those begin with a 1. And if you did a quick survey of the area codes in other states, you'd find that as well. So, how many different combinations are there? Well, if I cannot, and this is where your color coding comes in, if this cannot be 0 or 1, then the number of choices that I have here is 8. I got 2, 3, 4, 5, 6, 7, 8, 9. Now, if I am not putting any restriction on the other 2 digits, then I have choices there of 10 and 10 each. So we're looking at 800 choices total. Now, keep in mind that these area codes cannot end in 11. So, 911 is the emergency number, obviously. 611 is a number that you can call your cell phone carrier for customer service. 211 is a common number used in many communities like Des Moines for community information or to connect you with United Way or something like that. 511 is a common one that's used for traffic information or road conditions throughout a state. So, and that use just depends on the area that you're in. So there are 8 of those numbers that we can't use. So I better subtract those out, and I'm going to get a total of 792 area codes. Now, as I say this, there's also other numbers and prefixes that can't be used. There are several like 800, for example, or 844. Those are toll-free prefixes. 900 is one that you call for premium services and things like that. So that's the sort of thing that you need to watch out for. But, if we just talk about those alone, 792 is the number. Okay, now what if we had no repeating allowed? Okay, go back to your lock there for just a moment. Well, we've got an interesting scenario here where we could have, let's take a look. You could have any of 36 choices. Let's say that you choose a C to be your first character in your lock. Well, now you can't use that for the remainder of the combination. So you've eliminated that as a choice, and now you're down to 35 choices for your next character. And then once you pick that character, you've eliminated that one as well, and now you're down to 34. So we have now cut down to 42,840 possible combinations if you are not allowed to repeat. Okay, now here's a problem that will make anybody say, because we have the magic words "at most." Oh goodness. Anytime we see the words "at most," "at least," "no more," "no less," this means that we need to consider several different cases and add them together when we're done. Okay, so how many combinations are possible if one character, at most one character, can be a number? Oh dear, dear, dear. Okay. Now it doesn't say anything about repeating here, so I'm going to assume. Well, actually, I'm going to go ahead and throw in this just for extra practice that no repeats allowed. Okay. All right. So at most one character can be a number. Well, I want you to think about what that might look like here with the different cases. One case is you have one number, and another case is you have no numbers. Okay? So we'll talk about maybe an extra frill to this in just a second. But if we're talking about only one number, let's say you choose that number first. Well, there's a 10. You can pick from any 10 of those. And then you have to pick your letters now. And the letters, you have 26 choices for the first one and 25 for the second one, because no repeating is allowed. No repeating is allowed. No es permiso, as they say in Espanol. So that's 6,500 choices. Now, hold on a second. What we've done here is we've considered the case where that number is picked first. If that number is picked second or third, you're going to have that many cases twice over in addition to the 6,500. Okay? Now, because we are going to be complete here, it could be or here that you could pick the number. So really what we need to do is multiply this by 3 to represent the number of times or number of different places that I could pick that number, and it's 19,500. Okay, now let's think about the case where there are 0 numbers. Well, that's 26, 25, and 24, and when I multiply all of those out, that is 15,600, and then I add that to my 19,500, and I have a total of 35,100 combinations that have at most one character being a number. That's still a lot of them, which is good to know. All right, now this is one of my favorite examples here, is this game from The Price is Right. Those of you who know I'm a huge fan of game shows and always loved The Price is Right. Watched it with my grandfather when I was a kid, when we would visit to see them, and still watch it to this day. And this is a pretty fun game. And the name of this game is called Cover Up, and you notice that this is a pricing of a car is what it is. So the contestant has to come up with the price of a car, and it has to be selected from all of these digits that you see here in the picture. Okay, so in this first digit of the car, which they'll select, it's got to be the 2 or the 3. They've got to pick one of those numbers and put it here. And then for the second one, 1, 8, or 6. For the third digit, 8, 7, 9, or 5. And so on and so forth down the way. So how many ways can we select the price of this car? Well, there's 5 different choices that you have to make. And there's 2 choices for the first number, and 3 for the second, and 4 for the third, and 5 for the fourth, and 6 for the fifth. And when you work all of that out, there are 720 different ways to select the price of the car. So you've got a pretty remote chance of winning this game on the very first try, unless you really know something about the price of cars. The way this game works is that if you make a selection of the price of the car and you get at least one number right, then you can have another crack as long as you are progressing towards getting the correct price of the car. So, you might get the first number right, and then if you get this one wrong, well, you still have an opportunity to pick from the remaining numbers to cover up this one and try again. Excuse me, and all the way down the line. So hopefully a contestant will do pretty well on this. Tough game to win. And that's kind of important here because sometimes these games on The Price is Right, or even some more situations like this, you never know when these combinations or this idea of a counting principle may come to mind. All right, everybody, come on down to your sample problems.